Hello guys, very good morning. Welcome back to the sessions. We are in day 26 session. Yesterday we have seen the difference between comparable versus comparator and how exactly we can sort the data um, based on our own customized sorting technique. And we have applied, and then by overriding the compare to method and compare method, and I have shown you the different examples, right? So now uh, with that, actually, we have completed the 1D collection framework, especially the collections, list set, and sorted set. All these things we have seen, and now we have the rest is pending is something like two-dimensional collection framework. Okay, so two-dimensional collection framework meaning is here. So far, we organized the data either in the form of row or column, but using two-dimensional collection framework, we can organize the data in the form of key comma value pair. Okay, so to key comma value pair, if you want to organize the data like this, then definitely we should go for two-dimensional collection framework. So to achieve or to organize the data like this, we do have some predefined interfaces are there. Map, okay, sorted map, okay, map dot entry. Okay, like this, some predefined interfaces are there. Like how exactly we have different interfaces are there in one-dimensional collection framework. In the same manner, in the two-dimensional collection framework also, we have a few implementation. I mean, interfaces are there. So the root interface is for two-dimensional collection framework is what? Map itself. So map.entry is the inner interface that I'll tell you later. So for this map, map is the predefined interface. 1 second, please. Map is the predefined interface. Here, if I'm opening map API in Java, okay, it is map API in Java, docs.oracle.com. Here you see, if you read this, java.util is the interface, an object that maps keys to values. A map cannot contain duplicate keys. Each key can map to at most one value. This interface takes the place of the dictionary class, which was totally an abstract class rather than an interface. The map interface provides three collection views, which allow a map's content to be viewed as a set of keys, collection of values, or set of key value mappings. So we have some information is there, but what we are understanding from here, to organize the data, to store the data in the form of key comma value, then we should go for what this map interface. And if you're observing, this is the inner interface, meaning that map is an interface, entry is an interface, meaning that so inner interface concept is there actually in Java. So what does it mean? Here, if you're observing inner classes, inner interfaces, this concept is available in Java. So here the concept is already interface is there. What is the interface name? Map. Inside the interface, they have one more interface, that is what? Entry. Okay, like this. So this kind of interface is what we call, inner interface. So if you want to access any properties of this inner interface, we need a outer interface name itself. How can you access? Then map dot entry, like that we are going to access. So whether it is going to be applicable for inner classes and as well as what inner interfaces. If anybody is asking what do you mean by map dot entry, entry is the inner interface of map. Map is the outer interface. Like that, you please try to remember. Okay. So, and we have some predefined methods are there. So far, to add the data, we are using add method. Okay. So in the same manner, to add the key comma value pair to your map object, we are not going to use add method. Okay, we are going to use put method. Okay, put. So I think, yeah, here it is there. See, put of key comma value associates the specified value with the specified key in this map. So like this, so many methods are there. Is empty, key set. It is giving you the set view of keys contained in this map. For example, I'm adding keys as a student IDs 100, 101, 102, 103, like that. If you call the key set method, it will give you the set view of those keys only. So like that, replace, size, values, like this, so many methods are there. So inside the map itself. But map is an interface. You can't create the object. But for this map, these are all the implementation classes. You see, hash map, okay, linked hash map. So all these are the different implementation classes are there. If anybody is asking, What are the implementation classes are there for this map? So you should tell something like this. Map is there. So for this map, sorted map is the sub interface. Okay, for this map, there are two implementation classes frequently we are using. What are those? One is a hash map. Another one is what? A linked hash map. Try to like what remember, sir. Try to like what remember. Here, this one is hash map. Okay, and this one is something like linked hash map. Linked hash map like this. These are the two implementation classes. And for the sorted map, one more sorted map is the sub interface of what map itself. Okay, sorted map is the sub interface of map interface. For this sorted map also, one more implementation is there. What is that? That is the tree map itself. You need to understand the hierarchy first. You need to like what understand the hierarchy. This is the hierarchy, sir. Map and sorted map are the two interfaces. Map is the predefined super interface of sorted map. For this map, we do have two implementation classes. One is hash map, another one is what linked hash map. For the sorted map, another implementation classes is there. That is what tree map. Of course, from one implementation class to another implementation class, there are some differences are there. Based on our requirement, we are going to choose those implementation classes, like how exactly we have seen in case of one-dimensional collection framework. So you need to understand few properties about map itself. When should you go for what? Whatever I drawn just now, that is the map hierarchy. Okay, that is a map hierarchy. So, and now map does not allow, here one more important point I'm writing, a map doesn't allow duplicate keys. Okay, but you can have duplicate values. Okay, hash map, linked hash map allow null keys and values, but tree map does not allow any null key or value. Okay, a map cannot be traversed. Like how exactly? What do you mean by traversed? Here I'm writing and then I'll show you. A map cannot be traversed, meaning that you can't traverse, you can't iterate the elements which are available inside the map. Why? Because of map does not contain single object. Map is a collection of key value and then key object and then value object. That is the reason you can't directly traverse. So that is the reason we have to convert that into set using key set method. Using key set method, once you call the key set method, it will give you the set of keys. Or else, if you call the entry set method, it will give you the entries. Okay, like that. By invoking, after you invoke these methods, then it will give you the 1D view. On top of that 1D collection view, we are able to like what traverse. That is what I'm trying to explain here. If anybody is asking what do you mean by hash map, hash map is the implementation class of map interface, but it doesn't it doesn't maintain whatever I'm writing. These are the little features, but it doesn't maintain order. It doesn't maintain any order. Like this, you need to remember. Insertion order is not preserved. But in case of linked hash map, what is this? It is also the implementation class of map. Implementation class of map. It inherits hash map class. It inherits what? Hash map class. That means that means what? Linked hash map is the subclass of hash map. That is the relation in between hash map and the linked hash map. But what is the difference between these two? This linked hash map it maintains insertion order, meaning that in which order you are adding, in the same order we are getting. This is the same kind of example I told you in the one-dimensional collection framework, especially while I'm discussing about the set. For the set interface, we do have two implementation classes are there. One is hash set, linked hash set. What is the difference? Same thing. Hash set is not following any order, but whereas linked hash set is following insertion order. The same kind of the properties are applicable for hash map and linked hash map also. But when it comes to like what tree map, tree map, you need to understand. Tree map is the implementation class. Is the implementation class of map or sorted map? Sorted map. Where sorted map is the sub interface of map. So I have drawn and then I showed you also. It maintains which order? Tell me. It maintains some ascending order itself. Ascending order. Ascending order. So that is the default natural sorting technique itself. So to add the data, we are going to use put method. Okay. For example, sir, put method. Why we are using put method? Some predefined methods. Put method. Why we are using? It is used to insert an entry. okay, into the map. What do you mean by entry, sir? Entry is a combination of key comma value object. So if anybody is asking what do you mean by entry in the collection, it is the combination of key object and value object. Like this also you need to like what remember. Okay. One more, put all method is there. Why we are using put all method? To add another map object. Okay. To add another map object. Like while I am discussing about one-dimensional collection framework, like how exactly we are using add method and add all method. To add an individual object, we should go for add method. To add a collection object, we should go for add all. I have shown you example also. In the same manner, if you want to add any other, okay, some other map object to the existing map object, then we will go for what put all. Okay, it is used to insert the specified map into the existing map. Like this, we are going to use. Like this, remove method is there, remove all method is there. Okay, set method, clear method, so many methods are there. You can just go through the API of the map interface so that you will get the clarity itself. Okay, now after map interface and its respective methods, we need to like what understand about what map.entry. As you already aware, what do you mean by map.entry? So I have told you already, sir, entry is the sub interface of map. It is a sub interface or nested interface. Of course, it is the inner interface. Okay, instead of sub interface, I can write a inner interface of map itself. So since it is an inner interface, so we will be accessed it by outer interface name only. What is that outer interface name? Map. So that is the reason map.entry name. Like this, you are going to access. So you know, it returns what it is returning. It returns a collection view of the map whose elements of this class, whose elements are of this class itself. So I will show you so that you will get the clarity itself. So inside the map.entry, we do have some methods are there, like a get key method. It is giving you only keys itself. Okay, get value, it is only giving you the value objects. Okay, so set value is for changing equals. So many are there, and along with that, we do have yeah, these are the different methods are there. But mainly we are going to use get key and then get value from the entry. Meaning that combination of key object and then value object. If I wanted to only access the key object, then access the get key method on top of the map.entry object. Okay, but how will you get this map.entry object? Which method you have to call? That is also one of the important point. Sir, inside the map interface, whether you are observing or not, key set is giving you the set. Okay, I think one important method is there. Yeah, you see here entry set method, which will give you the set view only, but set of map.entries, where map.entry is again combination of key object and then value object. So whenever you call the entry set method, it will give you the set of map.entries. Okay, set of entries. So those entries you are going to access it by outer interface. But these entries are containing key object and then value object. Observe the return type, very, very important. Returns a set view of the mappings contained in this map itself. You have to call the entry set method. So whenever the requirement will come, I will show you how exactly it is fine. Okay, now one program I wanted to show you. Just come to our package, new, take the class, define the test9, and I'm going to like what define the main method here. Just understand here. Okay, now I'm going to create the object of map m equals to new map. Immediately we are getting the error even though if you are importing. Why? Because of map is an interface. If it is an interface, we cannot instantiate. So that is the reason we are going to create an object of its implementation class. Of course, for the map, two implementation classes are there. One is hash map, another one is what? Linked hash map. I have told you the differences also. Hash map is not maintaining the insertion order, whereas linked hash map is maintaining the insertion order. So whether it is working exactly or not, we will see itself. Now, what I have to do is I wanted to like what adding the elements to map itself, to the map itself. How can you add the elements? M dot put method, object key comma object value. Key is also an object, value is also an object. Everything is going to be an object only. For example, 100 Rama. Okay, M dot put off. Okay, something like 200 comma 200 comma. For example, okay, Amit. Okay, so M dot put off. Okay, 45 comma something like John. Okay, m dot put off something like 67, okay, 67 comma something like Leshwi. So like this, I'm just adding a few, okay, data itself. Now I wanted to like what traverse the map. If you really traverse the map, definitely we'll go for what iterator, right? But iterator, okay, itr equals to m dot iterator method is not there, sir. Iterator method you can't traverse. That is what I said. If you want to traverse, first you supposed to like what convert this two-dimensional view to one-dimensional view. How can you do that? Map dot or else m dot entry set method you just call it. Sir, whether you are observing or not, entry set is the method which the return type is set, where set is the one dimensional. Once you get the data in the form of one dimensional collection framework result, happily we are able to like what traverse. So okay, entry set method I am just calling, entry set method I am just calling. So it will give you the set object set, okay, set object. I am just control shift o, save it, java.util.set. Okay, that's fine. So now we have to like what traverse. How can you traverse? Iterator itr equals to set dot iterator method. That's done. Now what we have to do? I wanted to like what apply the while loop, while of, okay, control shift o, sir, control shift o, java.util.iterator, while of itr dot has next. Okay, now everything is available in the form of entries, set of map.entries itself. Now if I am calling itr dot next, what is the return type, sir? Object. So this object I suppose to like what typecast to map dot entry. How can you do this? Map dot entry, entry equals to, sorry, map dot entry, entry equals to here map dot entry. Like this you are going to like what typecast, because you're not mentioning any generic type. That is the reason you have to like what explicitly typecast. Control shift o, map dot entry, control shift o. Okay, why we are getting this error? Converting to map dot entry so that we can get key and value separately. Okay, map dot entry. Okay, sorry, sir. E is the capital. Let me save this. Control shift o. Okay, that's fine. itr dot next method is returning object. So we are typecasting object to map dot entry. Why we are converting into map dot entry? Because of once we are converting to map dot entry so that we can get key and value separately, sir. That is my requirement. So now on top of the entry, sorry, you have to end it with semicolon, save it. So now we got this system.out.println entry dot get key method. I have already shown you just now, plus entry dot get value, like this, get value. Okay, save it. So in this way we are able to like what fetch the elements. See, I'm adding, I'm trying to traverse this map object. So because of that, I'm converting into like what entry set method, so that we got the set view. On top of the set view you call the iterator method. Once it is done, then you're able to access. For example, when I run this application, happily one by one we are able to like what get this data. See here, 67 Leshwi, 100 Rama, 200 Amit, 45 John. Meaning that, as I said, hash map is not allowing the order. So that is the reason we are getting in different order itself. So now along with that, I would like to cross check whether it is allowing the null values or not. Null I'm adding. Let me save this, save it. When I'm trying to run this, okay, null is also going to be added. And one more cross check I wanted to like what add. M dot put off duplicate keys. Okay, duplicate keys is going to be duplicate keys is not going to be possible. For that reason, instead of Leshwi, if I'm using Charvi for the 67, already 67 is there. For this key, the corresponding value is Leshwi, but now I'm trying to add the same key with a different value. So what is happening? So am I getting that? No, 67 Charvi. That means what? The existing Leshwi will be replaced with what? Charvi itself. So that means what? Duplicate keys are not allowed. But whereas m dot put off, okay, where 100 comma, come on please, 100 already there, the 100 associated value is Rama, but for this 100 I'm adding Leshwi now. I'm adding Leshwi now. So duplicate values are possible. When I try to run this, 100 is there. Sorry, you no need to like what add the 100 one more time. 101 Leshwi. When I try to like what run this, okay, here 100 Rama is there. Okay, we should add here also Rama. That is the thing which I wanted to tell. 100 Rama is there and 101 Rama is also there. Meaning that you are not allowed to add duplicate okay, key objects, but you are allowed to like what add duplicate value objects. That is what I wanted to convey. And Happily you are able to like what add the null key objects. Happily you are able to add the null value objects also. Duplicate key objects are not allowed. All these are the insertion order is not preserved. All these are the different properties of what hash map. Hash map. If these are your requirements, then we should go for what a hash map itself. So by calling the entry set method, it will give you the by calling the entry set method, it will give you the object. Okay. So the same example, if I'm applying the generics, how exactly it looks like? Okay, example on hash map. Can you please tell me the features? Hash map. Hash map features. Tell me. Hash map does not allow. Okay, duplicate key objects, but it allows. Come on, please. But it allows duplicate value objects. And one more important feature. What is that? What is one more important feature? Second important feature, it allows both. Okay, it allows null values for both key objects and as well as okay value objects. And the third one, hash map does not allow duplicate key objects, but it allows duplicate value objects. It allows null values. Insertion order is come on, insertion order is not preserved. So these are the different features and the example. If the above three are the requirements, then we should go for what hash map itself. Okay, so that is all about what this hash map. And still okay, now with respect to generics, I wanted to like what change it. So for example, generics. So generic means what here, integer and then string. Okay, that's the same thing here I'm mentioning, integer comma string. Let me save this. Okay, the generic is fine. Okay, here also it is expecting a integer comma, sorry. Let me save this. Okay, now I'm mentioning. So the warnings are gone. So now set the control, yes, control 1, assign statement to new local variable. Yeah, like this. So when you call the entry set method, it will give you the set of what? Entries, where entry is a combination of what? Integer comma string. So in this way, we are going to mentioning the generics itself. Now on top of this set, if you call the iterator method, what it will give you? Okay, what it will give you? Just observe control 1, assign statement to new local variable. See here, it will give you the iterator of entries only, but again entry is a combination of integer comma okay string itself. So this is how exactly we are mentioning the generics. Itr dot has next. Okay, itr dot has next. So now you try to understand. We need to like what typecast here? Because this time itr dot next method is returning what? Entries only. Because previously, since we did not mention the generics, it is returning what? Object. But right now it is returning what? One second. Itr dot next method is giving you, one second. Let me save this. Control S, control 1, assign statement to new local variable. Okay, it is an entry object, right? So it is an entry object. When you call the entry itr dot next method, it will give you the map dot entry, where entry is a combination of object of map dot entry is an object of entry is an object of map dot entry. On top of this entry, if you call the get key method and get value method, if you run this, happily you are able to like what get the same output. But ultimately, when you mention the generics, you no need to like what typecast. So directly you are able to like what mention like this itself. This is also kind of generic examples. Usually we are doing like this only with the generic examples, with generic syntax, the above program. Okay, with the generic syntax, how exactly it looks like. So only the difference is here you have to like what typecast, but in case of this, you no need to like what typecast. That is only the difference. Okay, well, this is highly recommended to like what use. Okay, and that is all about what hash map itself. The same example, okay, same features are applicable. The same features are applicable here. Yes, you may ask one question. Sir. If you really would like to like what traverse these elements, still I am able to like what improve this. How can I able to like what improve? Only my requirement is to traverse, right? If I am removing this, I have a this elements is there. I wanted to like what traverse, so I can apply the for each loop. So, but what thing I have to mention here? Usually for each loop is taking the data type and followed by temporary variable name and followed by actual variable name. Okay, actual variable name. But here, what data type you have to mention here? What data type you have to mention? Data types are two data types are there. One is integer comma string. You can't mention, but that data type is representing what? Map.entry. Map.entry itself. Okay. So because of entry is holding two data types, right? And temporary variable name is anything. Actual variable name is what? Actual variable name is m, where m is the map object. On top of this, if you call the entry set method, then definitely it will give you the map.entry. It suits. Okay. Now what I'll do is 1 second. Okay, now here on top of this system.out.println of m dot get key plus m dot get value. That's it. Save it. So now if I run this application, okay, why we are getting the error? Okay, exception in thread java.lang.error unresolved. Why we are getting this error? 1 second. Elements can traverse in any order, but for map.entry, why we are getting this error? Okay, here do I need to like what mention integer comma string? I will save this. Okay, m already is there. That is what. That's not a problem. That can be considered as the local variable. Okay. If I run this, okay. Okay, since we have already mentioned, okay, here previously we did not mention this data type. That is the reason it might be not coming. Okay, so in this way also you are able to like what traverse the map elements using for each loop. Okay, so because you are not allowed to like what mention both integer comma string directly because of it is expecting only one data type. What is that one data type here? Map.entry, because map.entry is holding what? Key comma value object. So in that way, so that's such a fantastic concept here it is. You can't mention like integer comma string directly, right? So these two objects, these two types are holding inside one interface, one type, that is what entry. But to call this entry, we need map outer interface like that. Okay. So this is how exactly we can traverse the elements using for each loop. Using for each loop, okay, traversing map elements. Traversing map elements. All these are the different examples. Okay. So after this, if I'm asking immediately, okay, so same kind of example. If I'm just changing the implementation class from hash map to like what linked hash map. So just observe, remaining everything is fine, but only if I'm running this, you will get the data in how exactly how exactly you are adding the data in the same order we are getting. That is only the difference between hash map and then linked hash map. That is only the difference between hash map and then linked hash map. So linked hash map, okay, versus hash map. Okay, so the difference is I mean all the properties of hash map are applicable to linked hash map. Okay, but except linked hash map, okay, follows insertion order. Okay, in case of that means what? Insertion order is preserved. In case of linked hash map, in which order you are adding, in the same order we are getting itself. That is what you need to understand. Itself. Okay. So that is one thing you need to understand. And linked hash map is that. And we will go to like what next interface, that is what? Sorted map. Sorted map is what? Sorted map is the sub interface of map interface. Okay. Sorted map is the sub interface of map interface. And for this sorted map, tree map is the implementation class. But for this, in this tree map also, we have some implementation. You have some specific methods are there, like in like how exactly tree set has. In the same manner, tree map is also having some specified methods are there. Tree map class API in Java. If I am clicking on this tree map, okay, see here. In this, so many methods are there. First entry, first key. Okay, some get method, head map. Okay, last entry, last key. Okay, remove, replace, submap, tail map. Like this are there. we can cross check these methods. These are the some new defined methods which are available inside this. And when it comes to like this, here, if I'm changing from the linked hash map to like what a tree map, here I'm changing the map to sorted map. Okay, I'm just changing based on my requirement. Control Shift O is for changing this. Okay, but if you are trying to add this, immediately we are getting the class null pointer exception, I guess, because tree map does not allows. Okay, tree mapper does not allows what null. Okay, tree map, but that is the first point. Okay, tree map doesn't allows null. Okay, null properties are null both for key and then value objects. Does not allows null values, null keys or null values. If you try to add, we will get, okay, we will get runtime exception. We'll get runtime exception saying that, okay, saying that java.lang dot null pointer exception, observe the properties. Okay, so then according to our requirement, we have to choose the correct one, correct implementation class. Okay, is it possible? Okay, that is the reason what I'm doing. Immediately I'm just adding the null values. I'm just removing these null values. So now if I try to like what run this, okay, if I try to like what run this, still we are able to like what get this. But whether you are observing or not, 67 two times you are added, but only one time you are getting. That means duplicate keys are not possible. Duplicate keys are not possible. Duplicate values are also not possible. Sorry, duplicate values are possible. Duplicate keys are not possible. Duplicate keys are not possible, whereas duplicate values are possible. Okay, this is a second feature. And third feature, we will get in some ascending order. We'll get the data in some ascending order. In ascending order, that is the default natural sorting technique itself. Okay, based on the keys only, whether you are observing or not, based on the key objects. So if you observe the output here, 60, 45, 67, 100, 101, 200. Okay, meaning that based on the key objects, the values are going to be, okay, sorted, and then we are getting the data itself. This is the simple example of what this is a simple example on top of what a tree map example, basic example on top of tree map. Okay, so I can apply some other methods also. Still, now you just observe here. If I maximize this test 9, okay, so let me try to like what remove this. Now I'm applying, otherwise keep it not a problem. So now I'm applying system.out.println, just giving some separation. So now try to understand system.out.println, come on, m, right, m dot first key. Okay, when I'm trying to run this, if I'm running, only these methods are available inside the tree map only. So hope you understand. These methods are not available in the hash map or linked hash map. Only these methods are coming from sorted map. So that is the reason these methods are available inside the tree map object. So 45 is the since first 45 is the first key, then we are getting this. Okay, system.out.println of m dot last key. What is the last key? Tell me. Of course, I think 200, right? When I try to run this, okay, 200 we are getting. And system.out.println of m dot head map. For example, head map, if I'm giving 67, you just observe what is the output you are getting. When I'm trying to run this, 45 John. Head map is giving you what? Less than to this specified element, the values are coming. For this 67, okay, what is the less than element? 65, 45 and then John. That is that entry only we are getting itself. For example, here, if I mention like 100, I think 2 entries will come. Okay, I think 2 entries, 45 and then 67 will come. See here, 45 John and then 67 Charvi itself. So less than to the specified elements, the values are getting. And even if you are observing the output view, set view is coming. See, when you keep the head map, it will giving you head map is giving you what? Returns a view of the portion of this map whose keys are strictly less than 2 key itself. So that is what exactly the head map is doing here. System.out.println of tail map. For example, here also if I'm mentioning like 100, what is the tail map is giving you when I'm trying to run this? It will give you 100 greater than or equal to 100, 101, 200. It is coming itself. Greater than or equals to it is coming itself. That is the basic idea or else purpose of what using tile map method. When I'm trying system.out.put enough m dot, any other methods are there, subset submap is there. For example, if I'm giving 100, if I'm giving something like after 100 nothing is there, right? Okay, 200 is there. So if that is the case, 6700 we will give, or 4500 will give. Okay, 45 101 I'm giving. If I'm giving 45 101, whatever the target element, this one is not going to be included, but 45 will be included. 45 67 100 will be coming. That is what I'm expecting. See, you just observe here, 45 67 100, meaning that submapper, okay, whatever from key is going to be included, and then this two key is not going to be included. In between, all the value is coming itself. When I'm trying to run this, you will get the output is something like this. You can observe the, by seeing the output only, you can observe the, you can find out the purpose of using this kind of methods itself. Okay, the same kind of methods are already available inside the set, but those methods are different. But these methods are belongs to sorted map. Those methods are belongs to sorted set. Okay, so that is the difference between first key, last key, head map, tile map, sub map. All these are the methods which are going to be applied. Control C. If I'm giving, okay, one more example here itself, and where whether you are observing or not, the data is going to be always sorted on based on some default sorting order itself. For example, run it. Okay, now this is all about what sorted map and its implementation class tree map. Now it's fine. We have seen hash map and then linked hash map also. Now try to understand after this. I wanted to like what apply. I wanted to like what add the user defined objects. Sir, how can we add the user defined object? Is it possible to add the user defined object? Is it possible to add the user defined object to the sorted map? Yes, of course it is possible, right? How it is possible? You just try to like what understand. 1 second. One second, no? You just try to like what, apply the basic method like put all, remove. Okay, all these methods you just check it once. Okay, that's not a great challenge for us. For example, if I'm adding integer comma, for example, if I'm adding student, okay, integer comma student, student ID, and whereas a book is having student is having student ID, and then otherwise you can mention anything. For example, address ID. Okay, for example, book. Let me save this. Okay, here also book I am adding, where book is maintaining book ID and then book name and then book author. So many are there, but I am just adding book ID and then book name. Okay, if I'm coming back to here, let me try to like what new. They take the class book, where book is having private int book ID, private string book name. That's it. Save it. Let me try to like what source, generate getters and setters, select all, generate. Let me try to click on the source, generate constructor using fields. Okay, after this public book, this is the default constructor, and I'm overriding toString method also. Okay, let me try to like what source, generate toString method. Okay, I'm just defining the book class, whatever you need. But here I'm just getting the data because right now, yeah, you just observe now what I'm trying to add. Okay, first try to like what create the book object, create a create book object. Okay, create a book object. Book b1 equals to new book of, okay, where something like 1 comma Java is the book name. Book b2 equals to new book of, okay, 2 comma Angular. Let me save this. Book b3 equals to new book of 3 comma Spring. Like this I'm adding. So b1 b2 b3 are the book objects. Now I am just trying to like what add m dot put off. You just observe m dot put off 100 comma is the student ID b1. Then the error is gone. Put off 101 comma b2 m dot put off, okay, 40 400 comma B3 itself. Like this, I'm just adding. So 3 objects I'm going to like what add. How can I traverse this? How can I traverse this? Instead of string, what I have to mention? Book itself. Okay, let me save this. M dot get key, M dot get value itself. Okay, let me try to like what remove this since we have already took the backup. Now, if I try to like what run this, so you just observe here 100, 101, 400, where it is giving what book ID, book name. Why we are getting like this? Since you override the toString method. Since if you are not overriding the toString method, you will get what, sir? You will get what, sir? Class name at the rate of hash code itself. Okay, class name at the rate of hash code, book ID plus book name. Okay, like this. Excuse me. Okay, so like this, if I'm adding, if I'm, of course, we can just change as per your requirements. If I run this, you just observe 100 is the student ID, and for this student, the respect to associated books are what? 1 Java, 2 Angular, 3 Spring itself. Why we are getting 100, 101, 400? Okay, if I'm adding like a 400, 101, and then if I'm adding 300, if I'm running this, and you just observe, as I said, based on the key objects only, the data is going to be sorted, because since our object is right now, it is the sorted map. Of course, it's a tree map itself. So that is what you need to understand based on the key objects. Okay, so the data is going to be sorted out. Control A, Control C. So in this way, okay, adding user defined object as a value object to the tree map, so to the not only tree map, it can be based on the requirement. You can add the same kind of object to the hash map or linked hash map also based on the requirement. Now my requirement is, of course, the requirements are going to be different, varied, right? Now my requirement is, I would like to add or else based on the, I think is it possible to like what sort the data based on, I mean reverse order? I want to like what reverse order. Is it possible? If that is the case, what we have to do? One second. Okay. So for this reason, okay. So in this way, we are able to like what, add the user defined object to my map related object itself, to my map related objects like this. So if I run this application, we are getting the data in natural sorting order. But what is my requirement is something like, I would like to like what retrieve this in reverse order. Huh? If that is the case, what we have to do? Okay, so one second, that also we will see it. So especially we have seen like, the different comparators, objects and all those things. Is it fine? Is it possible or not? We have to cross check. New tree map of here. If I'm adding new my comparator object, is this that kind of constructor is there or not there? I'm just cross checking. Okay, let me wait. Tree map, yes, comparator object is there, you see. So like this, happily we can do it. So for example, new my comparator, any name, not only my comparator, any class name. But with this my comparator, you have to like what define. Okay, for example, already student ID comparator is there, na? Okay, I am just using that student ID comparator. I'm just using that student ID comparator. Let me save this student ID comparator. Okay, why we are getting this error? The constructor tree map integer comma book student ID comparator is undefined. Okay. What it is expecting, tree map after this is expecting only constructor tree map. Okay. One second now. Since it is there, we can easily utilize it, not a problem. 1 second, tree map. Yes, this one I am just checking. Comparator object. New my comparator. Let me save this. Okay, why we are getting this error? Comparator, my comparator is not there. That is the reason. Define this my comparator class, which is implementing from comparator, interface. Comparator, why you are defining this comparator for what? For book, right? Or for a book or what? It's not for book. Is it test9, right? Previously it was there. If I'm using book, that's not a problem. Finish it. Come back to like what test9, save it. Save it. The type my comparator is not generic. It cannot be parameterized with arguments itself. Okay. Okay. Let me cross check it 1 second. So just come back to like what comparator implements my comparator. If I'm removing this, not a problem. Object O1 comma object O2. Okay. So what we have to do is, since it is a string ID, okay, of course you have to like what mention integer only. Okay. So if that is the case, if you mention like an integer, and these are also like an integers only. Yes, I got it. Here also you have to like what mention, observe it first. Whatever we did yesterday, the same thing I am doing here itself. Return O1 dot comparative of O2. That's it. The simple logic. I'm not writing the entire logic itself. Okay, now come back to like what test9. The error is gone. If I run this application, it is just giving you the natural sorting order only. But when you are changing this sign or O2 dot comparative of O1, obviously based on the key objects, it is coming in reverse order itself. That means 400 it will come first, 300 and then 101 itself. When I try to run this, you see 400, 300, 301. Okay, now my requirement is based on the student ID. Since student ID is an integer type, I am able to like what sort the data. Now my requirement is I wanted to sort this data based on my book object data, especially book name. I wanted to like what sort it. So if that is the case, Angular will come first, Java will come later, and then Spring. So if you see the output now, okay, now 1 Java, 3 Spring, 2 Angular. But what I want, 2 Angular first will come, 1 Java will come, 3 Spring. Based on the book name, I am trying to sort. So if that is your requirement, how can you do this? It's very easy. For that, try to like what define one more comparator. What is that comparator? Tell me. Let me define this class. Book name comparator. Okay. Add comparator object. Okay. Comparator. Which of type what? Book. Okay. Fine. Click on the finish. Book name comparator. What thing you have to do? It's very simple, right? Return o1 dot. Come on, please. Return o1 dot. Okay. Why we are not getting this? Is it a compare to method? Okay. O1 dot get book name dot compare to method of o2 dot get book name. Okay. So that based on the book name in the alphabetical order we are getting, in the same dictionary order we are able to like what get this. So now come back to, now book name comparator is ready. So now come back to here book name comparator. If I'm passing same thing, why we are getting this error? Okay, the constructor tree map integer comma book name comparator is undefined. Okay, why it is undefined? For the value object, it's not possible to like what add something like that? Okay, only it is accepting keys only. If you are changing the book object as a key and then value object as an integer, then it will be fine, I guess. So make sure your user defined object must be key objects. Based on the keys only, we are able to like what sort it out. So that is the reason we are getting this error. If you really want me to change something like that, yes, you can change it. So what we have to do is book comma integer. Sir, based on the key objects only. So it is going to be happening. That sorting technique is going to be applied. That is the reason I am changing my key object, book object from value object to like what key object, and then I am changing it. And I'm trying to do it. Okay, these are all the different requirements. It is not like exactly the predefined examples. Based on the requirements, you have to see. The moment I'm just changing from value object to like what key object, it is allowing. So that means finally conclusion is what? The sorting technique, whether it might be customized or the default, based on the key objects only, it is possible. So now that is the reason what we have to do is this 400 control X B1 comma control V 101 control X. First I'm adding this 300 B3 control V. Isn't it? Is it correct? 300, right? B3 comma 300. So now I'm just removing. Okay, let me save this. This is fine. M dot entry set here also we have to change book comma integer. Let me save this. Yeah, now it's perfectly fine. So now if I run this application, book object is coming first 2 Angular, 101, 1 Java, 3 Spring. So whether you are observing or not, Angular, Java, Spring. So based on the book name, am I able to like what sort this data or not? Yes, exactly. Okay, in reverse order, try it. What we have to do? Go to the book name comparator, just change either O1 to like what O2, or just change the symbol. Instead of positive symbol, if you are using minus symbol, automatically that entire order is going to be different. When I try to like what run this application, now you see based on the book names only we are getting the data sorted out, but in the descending order it is coming. Previously it was Angular started with, but now it got started with what? Spring, Java, Angular itself. Sir, in this way you can play. Okay, when you have a knowledge, especially when you have the clarity on top of the these things, definitely you can based on the requirement you can make those changes, and then you are able to like what fulfill those requirements itself. Okay, this is one of the very important example using comparator and all those things. Okay, so sorting the data in our customized order, Okay, so one more important note point also I'll tell you, sir. This sorting note, this sorting happens, okay, happens based on the key object only. Okay, not based on the value object. That is the reason. Your user defined object also, must be the key object. So this is what you need to understand. So for this book name comparator also is required, right? My comparator sometimes is required here. So my comparator, when you want to like what sort the data based on the student ID, that time this my comparator class I used, and for the book name comparator, as based on this particular requirement, I'm just changing. Based on this particular requirement, I'm just changing book name comparator, Control C. Okay, Control V. For this, book.java is also required, where it contains book ID and then book name. Okay, so let me Control C and then Control V itself. So this is all about what the two-dimensional collection framework, map, hash map, linked hash map, and then tree map. Okay, and assignment or something like refer about hash table. Okay, and do one program on top of this hash table itself. This is your assignment itself. That is all about my today's session. So with this, I hope I am done with the collection framework. We will see some other concepts in my coming sessions itself. Okay. So if you have any kind of queries while you are referring this session, please try to keep it in post in the comment section, and please try to share this to your needy friends who are looking, who are going to become Java developers, who are looking to become Java developers. Please try to like what share this video like this way. Thank you. Thanks a lot.